Greetings to all the viewers. The session is covering with the compound called indole. Indole is alternatively known as benzofused pyrrole. In accordance with the IUPAC nomenclature, it is designated as 1H indole. IUPAC stands for International Union for Pure and Applied Chemistry, right? So, according to IUPAC, it is the 1H indole, and the session is powered by AI. AI driven session it will be, where you can notice it is the bicyclic ring system. One benzenoid nucleus is allocated. Another five-membered pyrrole ring taken part of this one. Together, it is a fused compound which is called a indole, right? So, indole is a benzofused pyrrole, and a three-dimensional representation is provided for the better understanding, where benzenoid nucleus with the carbon joined by the hydrogen atoms, and a five-membered ring system with the heteroatom blue color indicated nitrogen is manifested with the hydrogen linked one. And this is the way three-dimensional representation is provided, and all pi electrons are delocalizing in the entire system, which is represented by the circle mentioned rather than bonds, because always electrons having the provision to rotate. That's the reason why here mobilizing electrons are mentioned with the circle. So this is regarding the brief intro for indole molecule. Let me give the agenda of the session. We are going to get the introduction regarding this indole, what could be the occurrence for this molecule, where we can locate this one. This kind of introduction is provided in the session, in the section called introduction part. And synthetically viable methods on the laboratory platform and industrial methodology for the synthesis of indole are detailed discussion is provided in this section. Later on, we will enter into the segment called physical properties. What could be the nature of the compound, at what temperature it will melt and boils, and what general properties it will exhibit, all taken into the segment called physical properties. And whenever any chemical reagent to be operated upon this indole molecule, how it will react, what could be the chemical reactivity towards the kind of reagent we are adding. All these are together discussed in a chemical property section. Later, we will conclude with the potential applications of the indole, in which methodologies, in which dimensions we are supposed to apply this indole molecule. These many kind of things are taken into the session. Let me enter into the introduction part of this indole. So in order to introduce this indole molecule, indole is considered as an aromatic heterocyclic organic compound, and whose molecular formula is designated as C8H7N. 8 carbon atoms, 7 hydrogens, and 1 nitrogen taken part of this indole molecule, and there is a benzene and another pyrrole together got fused within the single compound. Indole is an important structural motif in many natural products, being it is extracted from the nature, so that natural products also having the composition of this indole. If you are considering amino acids are basically for the protein synthesis. Those amino acids composed by this indole, especially tryptophan is the best example. So many alkaloids also taken part of this indole, and even pharmaceutical drug curatives also the kind of indole based one, right? So these many applications you can observe for this one. And there is a representation for the indole, where 6-membered and 5-member ring systems are together fused over there, and nitrogen is given as the number one priority. Subsequently, let me go in the order, and the second carbon, third carbon. Let me take this fused ring, fused carbon atom, they may ignored, and later on third carbon, you may give the numbering in the benzenoid system 4, 5, 6, 7 in such a manner. This is the way numbering will be accorded for this indole molecule. And the same one can be represented in the three-dimensional pathway, where 6-membered benzene and 5-membered pyrrole will be taken in a conjunction, and pi electrons delocalization is provided with the circle, and bondless representation of 3D picture is provided for better understanding. Nitrogen is mentioned with the blue color, and all ash color lobes indicates the hydrogen atoms, and black indicated for the carbon. And we entered into the segment called significant applications of the indole in various plethora. Here is the compound called tryptophan, where you can locate the terminal carboxylic acid, and the adjacent alpha position is composed by the amino. This entire side chain is present on this indole. It is taken as a tryptophan amino acid. Amino acid is a starting material for the construction of polypeptide chains. Polypeptides are very essentially known as proteins. Proteins, everybody aware, those are the nutrients in the living organisms which used to enhance, which used to build up the system, build up the organs, right? So for that purpose, proteins are very essential. So the tryptophan is the part of that amino acid from which you can construct the proteins. Here we have solaphenol A. Solaphenol A is composed by indole and alkyl. In the alkyl side chain is located, which is effective antiviral drug. Virus can be effectively destroyed. Let me introduce another actinopolymorphol B. That is a kind of active trade marketed indole based drug. It will be in a curative device. So here we have Ajmalicin. Ajmalicin is a polyannular system. So many ring systems are located where we are having indole at this instance, and here is the saturated pyridine. And here is also the kind of saturated pyridine only. Here is the kind of pyran system, and here is the side chain ester, where indole is the effective pharmacophore in this trade marketed drug. Another polycyclic system with the polyannular bridgehead compound, so many complicated linkages you can notice within the skeleton. And here is the indole, which is considered as Catarantin. Catarantin is the kind of effective trade marketed drug which is composed by this indole. And here is the another drug you can locate polyannular system once again. And here is the indole nucleus you can clearly observe. And that is called tabersonine. Tabersonine is also the kind of effective curative agent in the field of pharmacology. And anti-inflammatory indomethacin is composed by this indole and side chain ether. And here you can locate the terminal carboxylic acid. Inflammatory conditions will be effectively curated by means of this one. Let me go with another one called pindolol. Pindolol is anti-hypertensive. High blood pressure conditions better regulated by means of this one, and blood pumping system will be effectively harmonically balanced, and hypertension conditions will be mitigated by regulating the secretion of adrenaline hormone. Metrollinindole is the kind of another drug you can locate where indole is taken as effective pharmacophore, and the side chain pyridine, saturated pyridine nucleus also taken part of that one. It is antidepressant, effectively enhance the activity of the brain. And this is the it is the indole sulfonamide kind of moiety you can observe. This is an anti-migraine agent used to treat the migraine conditions, headache conditions, effectively curated. Trade name of the compound will be sumatriptan. And this is another indole related drug you can observe. Here is the indole, another heterocyclic nucleus is the imidazole molecule is also taken part of this, sharing the part of this pharmacophore skeleton, and it is anti-emetic in nature, and then teron is the name of this compound. And again, once again, we have this indole sulfonamide moiety with the extended side chain over there. Which is called a delaveridine, which is effective antiviral agent. Viral infections will effectively curated by means of this one. Wherever sulfonamide is there upon this indole, that will intensify the activity towards this microbial action. Microbial growth will be effectively destroyed. And here is an alkylated indole is taken, and extended side chain is also there with a high number of polar functionalities, which is called a fluvastatin, which is anti-hypercholesterolemia. Anti-hypercholesteremia. Hypercholesteremia is nothing but a larger extent of lipid content in the blood. A cholesterol content in the blood, which causes the blood clot, so that blood pumping will become difficult. Heart failure may be possible if the cholesterol level increases in the maximum extent. That's the reason why cholesterol regulation is possible by means of this fluvastatin. which is an alkylated indole molecule, so that blood cholesterol levels will be minimized, so that heart pumping will be effective, and blood circulation is in harmonical manner. Sunitinib is a kind of anti-cancer agent where indolinone kind of nucleus is located over there, and another pyrrole is there, and tertiary amine is also the part of this one, so that intensified activity is accorded for the compound towards the tumor curation. And in order to locate this molecule in the nature, so many kind of origins, like a plant, animal, and coal tar are the kind of origins from which you can extract this indole, so that we can conclude the molecule as a natural product, being it is extracted from the plants and animals together, so that it is the kind of natural product. The kind of plant, Mitragyna speciosa. Metrogyna speciosa is a kind of plant you can clearly observe, from which hot water extraction giving rise to a kind of compound which is taken into the RB flask, where indole taken as a skeleton and a core molecule over there. This is a kind of plant extract. In addition, so many animals also from which you are able to extract this molecule in the form of indole. And even coal tar is composed by multiple hydrocarbon kind of compounds, and being it is a heavier molecular weight crude oil product fraction, so from which also you can extract this indole as a kind of product from this starting material. And even in the tryptophan amino acid, this indole is a kind of skeleton you can clearly observe. Just now we gone through that one, alpha amino acid, where indole taken as a core moiety, and this will be the precursor in order to synthesize so many molecules like serotonin and melatonin. You can observe here serotonin and melatonin, where indole is there and the terminal amine is there, and here the hydroxyl functionality. The serotonin secretion is very essential in order to minimize the depression conditions and activate the brain functioning. And it is designated as a neurotransmitter which enhance the activity of the nervous system. And indeed, it is regarded as a feel-good hormone. Feel-good hormone, it might be happiness and well-being is accorded whenever the secretion of serotonin is possible in our brain. So whenever secretion of the serotonin in the optimum level, so that our pleasantness will be retained or restored. Serotonin secretion is imbalanced, so that depression conditions will be imbibed into the system. Melatonin is the kind of derivative of serotonin itself. Whenever a free amine is there, that will be acylated, and free hydroxyl will be methylated, giving rise to methoxy, and in an acylated product that is said to be what melatonin. It is slightly resembling with serotonin only. It is working upon again the nervous system only. The people who are suffering with the sleepless disorderness at that condition, it is very pleasant to operate with this melatonin, so that sleeping tendency will be induced, right? So this is the way kind of indole derivatives are very helpful in the metabolism. And indole having multiple activities in the regular metabolism in the living organisms. Whenever this indole is going to bind with the heme in a hemoglobin is a pigment in a blood system. Red blood cells are composed by this hemoglobin as a red color pigment, and where globular protein will be there, and heme is the part of iron that having natural tendency to bind with the oxygen, and that oxygenated blood is transported into the various organs in the living organism, so that oxygenated blood is transported, and further metabolitic activities will be accomplished and giving rise to energy at each and every cell. This is the way natural process will be carried. Whenever indole is supposed to be bind with this heme, that oxygen content uptake will be enhanced, so that aerobic metabolism will be intensified later on. This indole may bind up with the serotonin receptoric site, so that able to reduce the stress conditions and improve the brain quality of the brain will be enhanced, being it is a feel good hormone, and behavioral conditions will be well organized, and it able to induce that food intake capacity is also increased. This indole also works upon the radical species. Free radical species, it works upon, so that oxidative antioxidative agent it will be. Whenever radical species are multiplying, what happen, they able to increase the number of cells by uncontrollable division and giving rise to a kind of tumors as well. So that it is a indole is a kind of antioxidative agent as well, which able to destroy these scavenging free radical species as well. And let me go for another immunity boosting system where it able to bind with the aryl hydrocarbons receptoric site. Whenever indole is binding with aryl hydrocarbon receptoric site, immunity defensive system will be improved, and the standard towards fighting against the various pathogens like microorganisms, bacteria, virus, any kind of pathogenic organism, protozoan, and worms may enter inside if the weak immune system is there. If immune system is perfectly balanced, so that the kind of defensive against those many pathogens we are able to fight, and diseases may not reach the person in general. So this is the way the indole also working in a immunity rising tendency, and it is also having working upon the adrenoreceptoric antagonist, and it able to suppress the secretion of adrenaline hormone, that is that able to adrenaline secretion is able to improve the blood pressure, so that high blood pressure conditions giving rise to anxiety, tension, and also kind of imbalance in the entire metabolism process, that entirely destroyed by means of this indole able to antagonize this adrenoreceptoric site, right? So smooth functioning of blood pumping is possible, right? It able to bind up with this microorganisms in a intestine, so that intestinal health will be improvised. This is the way metabolic activity is positively impacted by means of this indole moiety. Let me enter into the segment called synthesis of indole. How many ways are there in order to synthesize the indole in a laboratory viable scale and also in an industrial scale method as well? The most familiar and important method of indole synthesis will be Fischer indole synthesis. Very familiar and the most widely applied method is Fischer indole synthesis only whenever phenyl hydrazine is supposed to condensed with either aldehyde or ketone, in general carbonyl compound under elevated temperature, pyridine generally taken as a catalyst in this kind of condensation reaction, giving rise to indole as a final product. In order to achieve this Fischer indole synthesis, multiple steps are adopted. Initially, phenyl hydrazine is supposed to be treated with this ketonic compound under acidified condition. Ultimately, ketone and hydrazine are supposed to be condensed by dehydration. Water is removed as a byproduct, giving rise to hydrazone derivative. Hydrazone derivative to be acidified, being acid catalyst is also applied over there, so that imine linkage, this nitrogen is taking this proton, and whenever this proton is taken by the nitrogen, the pi electrons are moving towards the nitrogen, and subsequent adjacent carbon atom is able to remove the hydrogen, and this sigma bond is taking the part of pi bond formation, so that initially we have imine linkage, later it will be migrated into a olefinic linkage. The olefinic linkage, whichever generated, is active in nature and immediately go for the ring cyclization by reacting with the benzene ring. Benzenoid system will be disturbed certain extent, and there is a new carbon-carbon bond origination is possible, and this nitrogen-nitrogen bond is highly unfavorable due to lone pair repulsions in the adjacent position, so that immediately bond will be cleaved. Ring opening is possible at this instance, and this bond is moving toward this one, and imine. Both the terminal imine linkages are originated later. That imine linkage will be protonated with the acid catalyst, so that nitrogen will be protonated, and immediately another imine is taking part of the ring cyclization, and adjacent NH2 and hydrogen will be removed in the form of ammonia, and giving rise to restoration of this aromaticity by a pi bond formation at second and third carbon atoms. Ultimately, indole is originated as a final product. Let me introduce the second method is called Madelung synthesis. Madelung synthesis prefer to be N-phenylamide is taken as a starting material to be treated with excessive quantity of butyl lithium. This is a strong base operated upon this. In order to perform the condensation reaction, obviously, elevated temperature is necessary so that this amide to be treated with this butyl lithium, giving rise to a final indole as the final product. In order to achieve this one, initially base able to abstract this hydrogen so that nitrogen is acquiring negative charge. At the same instant, in either base being, we are taking excessive quantity of base so that adjacent position we are having the alkyl side chain which is to be deprotonated, giving rise to carbene. Carbene is working like a nucleophile to be condensed with this carbonylic carbon atom so that there is a ring cyclization occurred. Whenever ring cyclization is accomplished, this negatively charged oxygen is there. Here also we are having negatively charged nitrogen that will be protonated under acidified conditions. You are gaining this NH. Later on, again protonation is accomplished upon oxygen as well, giving rise to OH. Okay, whenever H, OH are present, adjacent positions to be dehydrated, giving rise to this double bond in between the carbon and carbon so that indole is generated as a final product. Very simple synthesis base to be taking H positive, and later on we are going to add protons to the nitrogen and oxygen as well. Later on dehydration is performed, giving rise to substituted indole as the final product by the method Madelung synthesis. Bartoli indole synthesis is accomplished by taking nitrobenzene as a starting material and to be treated with a vinyl Grignard reagent. Or NGX is designated as a Grignard reagent. Instead of R, we are taking vinyl lengthier alkyl side chain so that a vinyl Grignard reagent to be taken in the excessive quantity. Tetrahydrofuran is taken as organic solvent media and to be operated at the temperature extremely low, -40 degrees is optimum, giving rise to indole as the final product. In order to achieve this reaction, initially nitro group is active towards this reaction with Grignard reagent, and the carbon wherever present in this in between the magnesium and this in this double bonded carbon, this pi bond is moving towards this carbon atom and this able to bind up with the oxygen so that O alkylation is possible. Whenever O alkylation is possible, either negatively charged oxygen obviously taking this MgBr, and this MgBr to be removed, giving rise to this sigma bonded electrons for the double bond formation, and the entire alkoxy bond will be departed from this nitrogen so that nitroso functional group is originated. Nitroso functional group is again reactive, super reactive towards one more molecule of Grignard reagent, and again carbene ion having tendency to bind with oxygen. O alkylation is the condition as above. After that alkylation, again it will go for this new carbon-carbon bond formation within the molecule rearrangement is accomplished. When here the benzenoid pi bond is taking part of the sigma bond formation in between, and this pi bond is moving towards the oxygen atom so that nitrogen oxygen bond will be cleaved and a ring opening at this instance is possible. There is a aldehyde at one terminal and imine at another terminal will be originated. At this instant, this magnesium bromide will be removed, and these bonded electrons are taking part of bond formation in between the nitrogen to carbon, that is said to be ring cyclization. Subsequently, oxygen is acquiring negative charge, and let me add another mole of Grignard reagent, and that carbene is able to attract this hydrogen from this bridgehead carbon atom so that benzenoid molecule is retained, and this pi bond is moving towards this nitrogen atom so that in negative will be achieved, and wherever O negative is there, oxygen negative is there at this terminal will bind up with this magnesium bromide. OMgBr will be at position number 2. This negatively charged nitrogen is protonated by this water molecule acidified condition so that it is protonated. Later, OMgBr will be hydrolyzed and giving rise to OH, and subsequently dehydrated, giving rise to indole as the final product. This is the way Bartoli reaction is accomplished by taking nitrobenzene and treating with the Grignard reagent, vinyl Grignard reagent, so that alkylation and subsequent ring cyclization and subsequent reactions giving rise to 3-methyl indole as a final product. I'm taking another method for the suitable synthesis of this indole. Now 1,4-diketone is one of the starting material. Ammonium acetate is the reagent for this kind of reaction, and excessive quantity is required. Palladium carbon is working like a dehydrogenating agent, like oxidizing agent in general. So that this ketone is supposed to be condensed with this ammonium acetate, giving rise to indole as the final product. Alpha iodo is one of the starting material and ketone to be taken as the excessive quantity. There is a probability to go for the condensation between the nitrogen and oxygen. Always, ketone having natural tendency to condense with the ammonia and ammonia related derivatives, so that there is a condensation. Later, in the presence of strong base like a potassium tertiary butoxide, strong base is able to generate this carbene ion over there. That carbene able to bind up with this carbon atom, giving rise to a ring cyclization that is indole. This is the way alpha iodo is supposed to be condensed with this ketonic compound in the presence of strong base, giving rise to indole as the final product. And another named reaction under this category of the synthesis of indole is a Bichler-indole synthesis. Aniline is one of the starting material. Alpha haloketone is taken as a reagent to operate upon. This aniline is reacted with this halo so that HX will be removed, and enalkylation is the step. After enalkylation, this will go for the cyclization reaction, and this adjacent carbonylic carbon will be transformed into hydroxyl and subsequent dehydration, giving rise to indole as the final product. This is said to be Bichler-indole synthesis. In order to operate that reaction mechanism is also provided. Orthonitrotoluene and diethyl oxalate, right? So orthonitrotoluene and diethyl oxalate to be condensed in such a manner in the presence of strong base like sodium ethoxide, giving rise to indole as the final product. In order to achieve this one, there are certain steps what to be performed. Here is the ester linkage, here is the methyl group. In the presence of strong base, there is a origination of carbene ion. That carbene able to bind with the carbon of this one, and this able to remove this ethoxy moiety. Here the hydrogen, here the ethoxy, so that ultimately ethanol will be the byproduct, so that here upon this carbon atom, we got this C double bond O, and the adjacent whatever ester is there, that remained as such. This is the way we are having carbon-carbon mu linkage. Later, let me heat the compound under acidified hydrated conditions so that ester will be hydrolyzed into corresponding carboxylic acid. We got alpha ketocarboxylic acid, which is an acid derivative, right? After getting this one, zinc and acetic acid mixture together working upon this one. Zinc acetic acid is a kind of reagent able to reduce this nitro group into the amine functional group, so that we are able to transform this nitro into amino. Amino will obviously go for condensation with carbonylic carbon, giving rise to ring cyclization. But here we have a carboxylic acid at the position number 2. That is said to be 2-carboxylic indole. The 2-carboxylic indole to be heated at the elevated temperature, so that decarboxylation is the consequence, and giving rise to unsubstituted indole as a expected product. Right? So indole will be originated by decarboxylation of this 2-carboxyl indole at the temperature 220 degrees centigrade. This is another pathway for the synthesis of indole. We have an industrial scale synthesis for the indole. One of the starting material will be aniline. Another is said to be what? Ethylene glycol. Ethylene glycol stands for vicinal dihydroxyl. Ethane is said to be what? Ethylene glycol. Ethylene glycol to be condensed with this aniline molecule at the temperature of extremely large 200 to 500 to be operated, so that entire reactants to be vaporized. At the vapor phase, extent of interactions will be larger, extent of reaction will be larger, ultimately extent of product purity will be larger. So higher yield of the product will be achieved at the elevated temperature. Moreover, catalyst used to improvise this reaction methodology, giving rise to higher yield of the indole at the industrial scale. This is the way aniline and ethylene glycol to be condensed, giving rise to indole as the final product. By that, we successfully accomplished the entire laboratory and industrial pathways for the synthesis of indole. Let me introduce the physical properties corresponding to this indole molecule. Indole is given with the name nomenclature, numbering, where obviously heteroatom will be started with numbering 1 and subsequently 2 will be accorded for the carbon, third carbon and fourth carbon benzene ring we entered into. And ignoring two bridgehead carbon atoms, always they overlooked. And fourth, fifth, sixth, seventh, this is the way numbering is provided. And corresponding molecular formula is C8H7N. 8 carbon atoms, 7 hydrogens and nitrogen taken part of this indole. And it weighs 117.15 gram per mole. Molecular weight is accorded as 117.15 gram per mole. Melting of this solid is possible at the temperature of 52.54 degrees, 52 to 54 degrees centigrade. So it able to melt at the temperature of 52 to 54 degrees centigrade. In order to boil this one, 253 to 254 degrees centigrade is applied. Being it is melting at 52 to 54, it existing in a solid nature. Most of the condition it exists in the form of colorless compound only. Certain extent pale yellow color is also accorded for this compound. Obviously, there is a aromaticity because of delocalized piloelectron system and planarity, sp2 hybridization. So many factors operated in order to justify aromaticity of the compound. Let me enter into the segment called chemical properties. So many generalized properties in the section of physical properties were completed. Let me introduce chemical properties of indole. Indole is said to be weakly acidic, just resembling this pyrrole. Being nitrogen is attached with the hydrogen. Nitrogen is more electronegative in nature, so that having natural tendency to pull up that bonded electrons, so that hydrogen is very feasible for release. So that is the reason why there is acidic nature accorded for the molecule. Whenever hydrogen loss, conjugate base whatever generated will be stabilized effectively by delocalization of resonance. More the resonance structures for indolite anion, more will be the stability, obviously. Acidic nature is evidenced by the reaction with base. Whenever base is acting upon this indole, there is a provision to pull up this H positive, giving rise to negative charge upon the nitrogen, which effectively stabilized by resonating with this carbon atom. Carbon also contributing this negative charge so that it is well stabilized. That's the reason why indole will go for further reactivity, either in alkylation or C alkylation. This specificity purely depends upon the type of reagent what we are adding. Indole will be selectively go for an alkylation whenever it is supposed to be reacted with a strong base like potassium hydride, and subsequent allylic bromide is treated upon, so that allylic substitution accomplished at the nitrogen. So, in alkylation is the obvious condition with 92% of the yield whenever potassium hydride is the base applied. This is a highly specified reaction. Instead, if you are treating this indole with this Grignard reagent, methyl magnesium bromide and allylic bromide is the same alkylating agent. Only the distinctive factor will be the kind of a reagent you are adding. Here is the nucleophile applied, which is comparatively weaker in nature, that will prefer. Carbon moiety is having natural tendency to prefer upon the carbon alkylation. C alkylation is a consequence and giving rise to 99% of C alkylation of the product that is operated over the second type of resonating canonical structure. This is the way the type of alkylation preferably depends upon the type of base what we are applying. And another question arises that why indole is said to be aromatic in nature. There are multiple reasons behind this aromaticity of this indole molecule, being it is a planar one, all the carbons and the nitrogen taken part of sp2 hybridization, so that planarity is the common criteria for the aromaticity. And moreover, importantly, it will go for the satisfying Huckel rule. Huckel rule stands for 4n plus 2 pi electron system is accorded for the molecule. 6 pi electrons are the part of this benzene ring and 2 pi electrons from the carbon-carbon double bond and 2 electrons contributed by the nitrogen. Together, 6 plus 2, 8 plus 2, 10 pi electron system, it will be 10 pi electrons are taken by the bicyclic system. So n is given as n is given by 2. 2 is the integer value. Whole number, obviously, it will go for obeying the Huckel rule and it will come under this aromatic compound. And all anhybridized p orbitals are taking part of that lateral overlapping, giving rise to pi bond formation. The pi bond formation above and below of the plane, there is a pi electron cloud will be originated. This is the way so many factors are specifying and contributing for the aromaticity of this indole moiety, indole molecule. And obviously, being it is aromatic in nature, and resonance is a common criteria for this indole, so many possible canonical structures are available. Whenever you are delocalizing the pi electrons obviously loosely bonded, having natural tendency to move and migrate here and there, so that the entire pi electron cloud is located above and below of the plane, and it is said to be pi excessive compound. There is an ambiguity in a C2 and a C3 substitution of the electrophile whenever electrophile is supposed to be bind at the position number 3. Position number 3 giving rise to nitrogen positive at greater the extent of charge separation. Whenever electrophile is going to be attached at the position number 2, least charge separation, least stabilization is noticed. That's the reason why C3 position is more preferable for the indole in order to go for the electrophilic substitution reactions. Let me perform the halogenation reaction by adding bromine as a common reagent upon this indole. Indole to be treated with the bromine in a catalyst pyridine, so that bromonium cation is able to sufficiently bind at the position number 3. 3-bromo indole as a final product. And it is possible for multiple ways of halogenation you can observe. Bromination is accomplished either by liquid bromine in the pyridine solvent, or else in bromosuccinamide in the presence of carbon tetrachloride solvent. The extent of product formation will be higher, and the position of the bromo will be a third. 3-bromo indole as the expected product. If you are treating with thionyl chloride, it is a chlorinating agent. Thionyl chloride is supposed to be give chloro indole as the final product. 3-chloro indole will be achieved. Let me add iodine in dimethyl formamide solvent. Potassium hydroxide is treated as a base, so that iodination is accomplished at the position number 3. This is the way multiple ways of the halogenation process are accomplished. All these comes under halogenation itself. Let me perform this nitration. In order to carry the nitration, nitronium cation is the electrophile operated by treating with the nitration agent, that is a concentrated nitric acid dissolving in a acetic anhydride. Acetic anhydride is facilitating this nitronium ion, which is electrophile, so that 3-nitroindole as the final product, you can accomplish 3-nitroindole as the final product. Nitration is carried over there. I'm treating with any other kind of nitrating agent that will be kind of C2H5CO NO. This is said to be what? Propionyl nitrate will be the reagent, and this is said to be sodium ethoxide, that is a strong base able to generate the nitronium cation. Again, here the nitration is accomplished at the position number 3, 3-nitroindole as the final product, right? So this is the reason to get the nitration. And here, otherwise, we are having HNO3 dissolving in acetic anhydride. But sulfuric acid and HNO3 mixture, which is said to be what? Nitrating mixture, right? Nitrating mixture not supposed to be operated upon the indole because it able to give the polymerization rather than the nitration. That's the reason why we are not supposed to operate with the nitrating mixture. The mild conditions are required in order to perform this nitration over indole. Let me go for the Wills-Mayer-Hack formulation. There are contrary factors operating upon the Wills-Mayer-Hack formulation upon open pyrrole and benzopyrrole. Open pyrrole is operated with the Wills-Mayer-Hack formulation with the phosphorus oxychloride and dimethyl formamide under aquated conditions, giving rise to formyl functionality over the position number 2. 2-carboxylaldehyde, pyrrole 2-carboxylaldehyde is the final product, whereas indole is operated with the same reaction conditions and giving rise to carboxylaldehyde functionality over the position number 3, because in indole, third position is more susceptible for the electrophilic substitution reaction. So that indole 3-carboxylaldehyde as the expected product you can achieve by Wells-Meyer-Hugh formulation. Let me perform the sulfonation reaction. Pyridine in conjunction with the sulfur trioxide to be operated over the indole, and 50 degrees temperature is sufficient to operate this reaction. So boiling water is required to accomplish this reaction, giving rise to indole 3-sulfonic acid as the final product. Acylation is performed over the indole molecule in the presence of acetic anhydride and sodium acetate mixture, giving rise to an acylated product, right? So acetic anhydride, acetic acid to be operated over the indole, giving rise to an acylation and C acylation as well. This is the way the acylation reaction is accomplished. After getting this polyacylated product, aqueous sodium hydroxide stirring is required at the room temperature so that N-acylation will be removed and C-acylation will be retained. This is the way 3-acetyl indole will be the product whenever acetic anhydride acetic acid is treated later on. Aquated sodium hydroxide will be stirred at the room temperature so that only 3-acylated product will be achieved. In order to reach N-acylation, so acetic anhydride sodium acetate is the suitable reagent and to be heated to the higher temperature, giving rise to N-acylated product. So here is the C-acylation, here is the N-acylation. This depends upon the type of reaction conditions we are applying. And then let me go with the alkylation reaction. In order to perform the alkylation reaction over this indole, to be treated with this methyl iodide in a DMF solvent, dimethyl formamide, so that we can achieve the C-acylation. Excess methyl iodide, if operated over there, so that polyalkylation is also possible. You can achieve this gem dialkyl at the position 3 and another alkyl at the position 2 and an alkyl as well. Tetramethyl indolium iodide as the final product you can achieve if excessive methyl iodide is treated. If quantified amount is added, only C-acylation, this is the product you can achieve, that is 3-methyl iodine, which is called scatol. Scatol, up to this only you can end up. Otherwise, you can continue the process by adding excessive amount of methyl iodide and the same conditions will be maintained and a temperature to be raised, giving rise to polyalkylation. And this is the reaction called manic reaction. Manic reaction is a kind of named reaction to be operated upon the indole and treated with this formaldehyde and this dimethylamine called a secondary amine, and aqueous solvent media is operated and reaction to be extremely quenched to 0 degrees centigrade, so that what happens? N-dimethyl alkyl substitution is generated over the nitrogen. Later, let me treat with the water and heat at heating to the higher temperature. And room temperature is also operated with the acetic acid. Water to be heated or else acetic acid to be operated at room temperature only. What happens? It will participate in the intermolecular rearrangement, and alkylation will be shifted to C alkylation, right? So that entire group, whatever generated at the nitrogen, will be shifted to this carbon atom, giving rise to the compound called graphene. Graphene is generated by this manic reaction, which is the most important scaffold in the field of natural products, and even in alkaloids. Graphene is the most important plant alkaloid it will be, right? Now, let me go for enalkylation of the indole. In order to operate this enalkylation reaction upon the indole, so many reactions we already gone through. Let me perform some more extendable enalkylation reactions. This indole molecule to be taken and can be treated with this reagent. The reagent whatever treated here is the alkylating agent whichever added here is the ester moiety is there at the terminal center, and here is the hydroxyl. The carbon is going to link upon this nitrogen atom. So this is the way this indole hydrogen will be replaced with this entire alkyl chain. C alkylation is accomplished by this kind of alkyl halide. And the same compound is also treated with this reagent. the solvent media will be replaced, ether will be replaced with the toluene, and room temperature conditions will be lifted to higher temperature so that another product formation is also possible. This another product is having alkylation. This another product is having alkylation. Uh, this alkyl groups already present over there. The reagent what we are adding here is a kind of ester containing aldehyde. The ester containing aldehyde to be treated over there. But if we are treating the reaction conditions at room temperature, it will be OHC double bond OET. And here is the OHC double bond OR will be generated. OR will be generated. That means whatever reagent we are adding, from that the alkyl group will be substituted. Instead, if ether linkage is taken, that diethyl ether solvent is taken, there is a provision to achieve this O-ethoxy also. That means ethoxy group is also generated. There is a slight difference you can notice by means of solvent utilization as well. So this is the way alkylation will be accomplished. Now, let me operate oxidation reaction over this indole. Mild conditions will be there, or else complete oxidation is also possible. Mild conditions where potassium permanganate or else lead tetraacetate, if operated, the reaction is able to accomplish the product called isatin. Or else hydrogen peroxide is the kind of oxidizing agent that is a stronger one and able to generate that indoxyl. Indoxyl is in turn said to be indigo. Indigo is the well familiar dye which is in blue color, which is composed by this indole nucleus. So here mild oxidation giving rise to a dye called isatin, complete oxidation giving rise to another dye called indigo. Let me show both the possibilities over there. If CAMNO4 is operated over indole, there is a provision to get the isatin. Isatin is the kind of diketone derivative of indole only. Whenever indigo is the kind of condition, that is the probable dimerized product. Dimerized product is achieved whenever stronger oxidizing agent is operated over there. So the dimerized product is said to be indigo, right? So this is the way both the probabilities are there for the oxidation of indole. Let me go for the reduction. Now we entered into the segment called reduction. Indole is supposed to be treated with zinc in the presence of hydrochloric acid. Selective reduction of pyrrole nucleus is possible without disturbing this benzene ring. If a palladium hydrogen is also the kind of reducing agent, again there is a provision for the reduction of the pyrrole ring rather than the benzene ring, right? But again, palladium hydrogen added in the excessive quantity. Excessive quantity addition is possible, that also able to reduce the benzenoid nucleus in addition to the pyrrole nucleus. So that complete reduction is also accomplished. This is the way. There are certain provisions for partial and complete reduction of this indole molecule. Let me go for this reaction with organometallic compounds. I'm going to treat with butyl lithium. Subsequently, carbon dioxide will be added. Indole to be treated with butyl lithium and carbon dioxide as well. Whenever butyl lithium butyl lithium is added, what it will do? It will remove this H positive and generates a N negative. N negative will be the effective nucleophile, right? Nucleophile going to attach to the this carbon atom that is electron deficit in nature, that able to generate the carboxylate over this nitrogen. The carboxylate electronic charge counterbalanced with Li positive and giving rise to lithium salt of N-carboxylate. Later, this tertiary butyl lithium to be worked over there. Tertiary butyl lithium used to pull the hydrogen from the second carbon atom because nitrogen is already protected, and that able to generate the carbene over there. Carbene ion is effectively go for the electrophilic substitution over there and giving rise to electrophilic substitution. Later, let me operate with the water. water will decarboxylate. So here is the hydrolysis, so that deprotection of this group nitrogen and giving rise to indole with the substitution over the second position. Second position substitution is very peculiar, but it is possible by means of this blocking nitrogen and giving rise to electrophile over the position number 2. So this is a kind of abnormal condition we can notice upon indole. Let me go for the oxidation of indole with N-bromosuccinamide and water as well, right? So indole to be treated with N-bromosuccinamide, so that bromo group will be given, or the position number 3. And it will be treated with the water. Water is giving rise to hydroxyl at the position number 2. That position number 2 hydroxyl is able to restore the aromaticity by dehydrobromination. And there is a hydroxyl functionality at the position number 2. This will be a enolic form and will be tautomerized into the ketonic form as well, giving rise to indole 2 ketone, right? So this is also the kind of oxidized product. And there are so many kind of chemical transformations are taken in the single slide. This is the kind of sulfonation reaction at the position number 3. And this is said to be nitration at the position number 2. And this is called halogenation. Bromo-iodo-chloro can be substituted at the position number 3. And this is a kind of formylation reaction at the position number 3, hydroformylation. And here is N-dimethyl carbamide and the POCl3 will smear Huck formylation, giving rise to position number 3. And this is formaldehyde and dimethylamine will be operated, giving rise to the alkylation at the position number 3, called the Mannich reaction. Gramine as the final product. Tin HCl, if operated selective dihydro indole, that is called indoline, is the product. Hydrogen nickel able to reduce the entire one, giving rise to saturated indolidine as the final product. This is about simple glance about the chemical reactivity of indole in general. By that, we successfully accomplished the chemical reactivity of indole. We entered into the application purview of this indole molecule. Indole, the effective application is indigo dye. Indigo dye is a kind of a dimer of 2 indole molecules that composed by C16H10N2O2. It is a molecular formula. Indigo dye will be there, which impart the blue color. It is a natural dye. Isatin is also the kind of oxidized product indole. You can notice the 2 ketonic functionalities over the position 2 and 3, and it is the dye you can clearly observe existing in a saffron color. And tryptophan is another application of this indole, which is the natural amino acid, is the precursor for the biosynthesis of the proteins. Tryptophan is composed by the indole, where the terminal amino acid means alpha amino carboxylic acid is the moiety you can locate. It is the polar molecule, and tryptophan is also the precursor for neurotransmitter serotonin and melatonin as well. Vitamin B3 is also, niacin is also synthesized starting from this tryptophan itself. And in the genetic matter, it is encoded as UGG. Then pharmaceutical applications for this indole are unlimited, and you can notice anti-cancer medications are available. Indole 3-carbonyl is a simple precursor, simple molecule with the effective pharmacophore functionality, and it is better curative for this kind of cancers, malignant tumors. And here we have indole nucleus within the molecule that is having antimicrobial activity. This indole nucleus is in conjunction polymerization with this another kind of quinolinone moiety, so that it is working like effective antimicrobial agent. And so many kind of agricultural applications are also the part of this indole. It is like a satin, like a dye. Herbicidal activity is imbibed for the molecule, where indole is accomplished with the carboxylic acid and chlorinated benzene at the position on the benzene ring of this indole, so that it is like a herbicide. Herbs, whatever weeds are there, get destroyed by means of this one. And pesticidal activity is incorporated for this alkyl side chain with the terminal carboxylic acid moiety over the position 3 of indole, which is the pest killing reagent. Anti-phytopathogens will be there. Phytopathogen in the sense which causes diseases on the plants are called phytopathogens. That kind of agent is also there, which is the as a compound of this indolinone, right? So this is the way agricultural applications are also the more proficient for this indole molecule. Serotonin precursor for analog of indole is taken. The serotonin is a very important precursor. Precursor stands for, it is the starting material for the synthesis of sumatriptan. Sumatriptan is meant for the curation of the migraine. The severe headache will effectively mitigated by this one. Anti-inflammatory activity is also prevented by this indole molecule. The drug whichever taken over there where indole with isoxazole moiety at the position number 3 was taken, that is effective against anti-inflammatory, which was clinically proven on rats. And hypnotic agent, it will be indole able to give the sedation and able to give regulate the sleeping disorders whichever present. Melatonin secretion will be improvised so that able to mitigate the kind of sleeping disorders, and the kind of indole molecule in conjunction with this ketone, and here nitrogen is together it is designated as a amide linkage, and here is the benzene ring, and a nitro group is taken over this benzenoid nucleus, and together it is designated as a melatonin. Melatonin is effective hypnotic agent able to give the sedation so that a sleeping tendency will be induced in the people. Plant growth hormones said to be auxins. Auxins are also composed by the kind of nature materials called indole. This indole 3 acetic acid is effective. Indole 3 acetic acid is the effective material for the growth of the plants, which is in turn regarded as auxin. Right, plant growth hormone auxin secretion is very important in order to regulate that growth factor. So regulate the cells elongation and the division. So that indole 3 butyric acid is also in either kind of auxin as well. A root development is possible in plant cuttings. Whenever we are cutting the plant and again we are planting, so in order to develop the new roots, the kind of indole 3 butyric acid is very essential. This is the way auxins are also the plant growth hormones composed by this indole nucleus. And there is another additional advantages accorded for this indole, that is a perfumery action. Being it is organic moiety having vaporization in the easy manner, that's why being it is aromatic in nature, aroma is the common consistency indicated by the compound, and flavor, it is having a perfume and a flavoring agent in the food industry as well, so that it works like a perfume. It resembles with the jasmine and orange blossom. So that is the way it able to give the odor upon diffusion. Material science applications also the kind of advantage by means of this indole molecule. OLEDs got constructed where dimerized indole molecule is the common composition of that one. Organic light emitting diodes. Light emitting diodes are the game changing field in electronics. So many kind of updated advantages we are experiencing by means of LEDs. LEDs again morphalized into organic LEDs as well. They're indole taken as a core moiety, right? And even polymerized compounds of indole taken as a chemical sensors as well. Chemical sensors and conducting polymers also recorded by polymerizing these molecules in n number. And semiconductors got constructed by means of indole skeleton core. By this, we successfully completed the entire session with the detailed explanation regarding the potential molecule indole, where it is originated, what could be the general synthetic strategies incorporated for that, and what could be the general physical properties exhibited, and chemical reactivity towards various reagents, and what are the various domains of the applications in different fields. Entire discussion is provided regarding this indole. Hopefully, it is more informative session for the scholars, researchers, academicians, and the kind of the competitive exam aspirants and entrance exam aspirants in the field of chemistry, in the field of organic, in the field of heterocyclic, in the field of natural products as well, in the field of pharmacy as well. The session is very informative in nature. Hopefully, you enjoyed the session. Thank you very much for your patient listening.